In this last video, we're going to be talking about hypothesis testing for quantitative variables. And similarly to when we did categorical variables, the mechanics are basically the same as with the one proportion, one mean, with slight differences. So we're looking at the difference between means. So y1 bar minus y2 bar. You can see the standard deviation formula for the difference is similarly set up when we did the proportions. It's essentially finding the standard deviation for one proportion, adding it to the other proportion, except this time we're looking at means. So we have sigma divided by n, sigma divided by n. Add those together, take the standard deviation, or take the square root. And if we don't know what the population standard deviations are, then we will use the sample standard deviations, and with the same square root of the sum. Then we can talk about the conditions. The conditions are the same as with one mean, with the added assumption that the groups are independent. Then the null hypothesis, we have the difference of the means, and we'll denote this delta 0, although it's usually going to be just 0. And then we have the t-score, similar to the z-score, and we take the difference of the samples, then subtract it from the population difference, which we're going to most of the time use 0, and then divide that difference by the standard error. And then the standard error again is using this formula. So those are the basic formulas, the basic idea, and you'll see that this follows very similar to how it is with just one mean. So we have this example. Is there a difference in the average price for a used camera people would offer a friend rather than a stranger? So we have 8 subjects buying from a friend, 7 buying from a stranger. Now the degrees of freedom, so the degrees of freedom here is not n-1. There's actually a formula for doing this. We don't need to get in the formula because the degrees of freedom will be given to you, but just always pay attention to that because it's not just a simple n-1 anymore. But it will be given, so we don't need to worry about the formula. So we do need to find the standard error here, and I guess we could also write the hypotheses. So we'll have mu1 minus mu2. We're going to assume a 0. And is there a difference? So again, is there a difference that tells us that the alternative is simply not equal to 0? So mu1 minus mu2 not equal to 0. We can find the difference in the y bars. So 281.88 minus 211.43, and that is 70.45. We can find the standard error of the difference. Will be the square root of 18.31 squared over n, which is 8, plus 46.43 squared over n2, which is 7. And we get 18.7048. We need to find our test statistic now. So that will be the difference in the sample means. So 70.45 minus 0 over standard error. And we get 3.766. And so we see if we're substantially more than 3 standard deviations away from standard errors. So this is going to be a very small p-value, but we can go ahead and find that. So set up our t-curve. 0 goes in the middle. This is a two-sided, so make sure you put both sides and shade away from the center. And so this p-value is using the t-distribution. So this will be 2 times TCDF. You go to second bars, pick number 5, and pick either the right shaded area or the left shaded area. It doesn't matter which one. So the lower bound, we do the right, it's 3.766. Upper bound, put 10 or 100, and then put our degrees of freedom, which is given right there, 7.62. And we get 0.006. And I don't really have room to write this out, but the conclusion reject the null hypothesis, and the difference does appear to be not 0. All right. So there are problems on the test review where you have to find a confidence interval for these two. It's easier if I just post another video where you can see what's going on the calculator. So I will post a separate video for that where you can see the actual calculator and what you're putting in. So if you have any questions, let me know.